Namaste and a very, very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, we will be looking at how to do chi-square test of association using SPSS. So please stick with me till the end of the video. We'll be learning something very interesting today. Now, to do chi-square test, let me just grab some data. I'll be going to File menu, Open. I'll just click on the option data. Let me choose the option employee data and say open. So this is the employee data set. These are the variables that are present in this particular data set. You have the variable ID, gender, birth date, education level, job category, what is the salary of the individual. You also have details like beginning salary, job time of an individual, which basically refers to the duration that he has spent working. Then you have previous experience of the individual, followed by whether or not he belongs to the minority community. Right. This is a brief description of the data. All are pretty straightforward variables, so you should not really have too much of difficulty understanding these variables. I will be mainly focusing on the variables gender and job category. Now, as you can see here, if I just click on the drop-down menu, you see two options here, female and male. So the variable gender has two categories, females and males. And the variable job category has three categories here, right? The first variable, the first category is clerical category, followed by custodial, and finally you have the managerial category. So let me just highlight these two variables. I've got the variable gender, and then I've got the variable job category. I'm interested in finding out whether there is any relationship between these two variables. Now, to find out whether there is any relationship between these two variables, what you need to do is, firstly, you need to set up your hypothesis. Now, to set up your hypothesis, what I'll do is I'll just quickly fire a PowerPoint presentation, right? Let me just label this. This is an example of chi-square test that we are doing. Remember, when you are setting up the hypothesis, there are 6 major steps that you need to go through one by one. And after going through these 6 steps, you will be able to say, you will be able to tell whether there is an association between these two variables or not. Remember that chi-square test is done when you have got two categorical variables. Don't do chi-square test when you have got scale variables. Please use chi-square test only when you have got categorical variables. There are 6 steps here. I will have to frame my H0, which is the null hypothesis. Now, what is the null hypothesis here? You can just say, remember, null hypothesis is the hypothesis of no change. It's the hypothesis of sameness. There is no relation between the variables gender and job category. So this would be my null hypothesis. I'm saying that there is no relationship. Let me just highlight this for you. There is no relationship between the variables gender and job category. Once you are through with this particular step, what you can do is you can frame the alternative hypothesis. The alternative hypothesis will be very, very simple to frame. It is exactly opposite of your null hypothesis. In my null, I'm just saying that there is no relationship. As far as the alternative is concerned, we have to frame it like this by saying there is a relationship between two variables. We are saying, remember, that there is a relationship between the two variables, right? So this is my null hypothesis, and this is my alternative hypothesis. These are the first 2 steps which we have to be very, very clear about as far as framing my hypothesis is concerned. Now, as far as the third step is concerned, what you need to do is you need to fix your level of significance. Level of significance is nothing but the margin of uncertainty in my decision making. I'm going to fix it at 5% here. Now, some people take this as 1%, others take it as 9%. Sorry, my apologies, 10%. So depending upon the case that you're working on, you can either fix it at 1%, 5%, or 10%. There are instances wherein you can fix it at 20% as well. That depends upon the situation under consideration, right? But for all practical purposes, 5% is a good choice. This is the margin of uncertainty in my decision making. Now, I'll just make a move on to the fourth step, which is nothing but my test statistic. What is my test statistic? It is nothing but chi-square test. I will be doing a chi-square test. Remember, chi-square test, I've said this earlier, at the cost of repetition, I like to say that chi-square as a test is done whenever you want to check whether the two variables are related or not, right? The fifth step would be the decision criteria. What would be your decision criteria? Now, there's a very simple rule of thumb. That is, you get the p-value from SPSS, right? You'll be getting your p-value from SPSS. Now, once you get the p-value from SPSS, you can compare the p-value with your level of significance. And if the p-value is less than 0.05, then you can conclude by saying that we will be rejecting our null hypothesis. On the other hand, if the p-value is bigger than 0.05, if the p-value is bigger than 0.05, right, you can conclude by saying that we do not reject our null hypothesis. We don't reject our H0. Right? So we've got our null hypothesis. So since this is part of decision criteria itself, let me just quickly remove the bullet point. So this is what I have, right? I have set my null hypothesis. I have set my alternative. This is my level of significance. What is my test statistic? That is chi-square test. What is the decision criteria? That is laid out very clearly here. If the p is less than 0.05, you reject your null hypothesis. And on the other hand, if p is greater than 0.05, you will be accepting your, I can't use the word accept. I'll just simply say I will not reject my H0 here, right? Now, SPSS or any tool has a responsibility to give you the p value and chi-square here, right? It is not the job of SPSS to frame H0 or H1 or level of significance. It is the researcher's decision to set up the null hypothesis. It is the researcher's work to set up the null hypothesis and the level of significance. SPSS has a responsibility to give you the chi-square. This is what is called as the calculated value, right? The last step that we will be looking at is nothing but your inference. This would be my inference, right? Now, I have not yet performed my chi-square test, so I do not know what is the chi-square value. I do not know what is the p-value. So I'll have to go to SPSS and request SPSS to give me the p-value. Let me just fire my SPSS quickly. So these are the two variables that I have, gender and job category. These are two categorical variables. Please click on the Analyze menu, Descriptive Statistics, and within this, you can just click on the option Cross Tabs. Why cross tabs? Because you've got two categorical variables. If you had only one categorical variable, maybe you could have done a pie chart and such things using the frequency option. I am not clicking on frequency. I'm clicking on the fourth option here, which is cross tabulation, right? Once you click on cross tabulation, a new window opens up, a new window fires. You have the row here and the column. Please click on the variable gender, enter it into the box below rows. You can just click on the variable job category. Please push it inside the box for columns, correct? I have got a row variable and I've got column variable here. These are the two variables, and I'm interested in finding out the relationship between these two variables. Now, at the bottom left-hand side corner, you have an interesting option which says display clustered bar chart. An ordinary bar chart would not suffice here. You need a clustered bar chart to show the relationship between these two categorical variables. So please tick mark this particular option. You have 6 different tabs here at the top right-hand side corner. Now you can just click on the third tab here, which says cells, right? Please click on the cells tab. You have a lot of interesting options here. I will not be showing all of these options in this particular video. By default, SPSS will give you the observed count, good enough. But along with the observed count, I would also want SPSS to display the row percentages. So please click on row percentages and say continue, right? Let me just see what is the initial output that I get. Right. There are 3 important details that you get here. One is the case processing summary, which just gives you the sample size and such things. I'm not interested in this. I'll just ignore this for time being. I'm really interested in the crosstab output here, right? When you see the crosstab output here, you can see the breakup that is given. You have 2 categories as far as row is concerned. You have female category as well as the male category. Now, it is giving you the percentage for the female category. Remember, when you add up the row percentages, it comes to 100%, right? Similarly, for the male category, also it comes to 100%. So what do I infer from here? In this company, there are 95% of the females are employed as clerks. You have 0% of the females employed as custodials. You have around 5%, approximately 5% of them employed as managers. I'm rounding off these numbers just for the sake of simplicity. So it's clear that mostly the females are working as clerks in this organization. You do not have one single female custodial. And finally, all the managers, I can't say all, I can say that roughly around 5% of the females are working as managers here, right? Now, let me just look at the male category here. Now, it's very interesting when you look at the male category, 60%, roughly 60% of them are working as clerks. 10% of them are working as custodials. And finally, you have around 28% of them who are working as managers here, right? This is as far as the male category is concerned. 60% clerks, 10.5%, 10.5% as custodials, and 28% of them as managers. Question is there any relationship between these two variables? Is there any relationship? Which means that does your gender influence the job category that you're in, right? Could there be a relationship between these two variables or not? Look at this. This is a very interesting bar chart. The bar chart only confirms whatever, it only describes whatever we saw earlier in the table. If you want, you can just copy paste this in PowerPoint and show this to your guide or show this to your mentor, right? This gives you a visual aid as to what we are looking at, right? Look at the legends here. There are three colors here: clerks, custodials, and managers. I see a bigger bar corresponding to the female category, correct? Female clerical category. The blue bar is bigger as compared to the male category. So you can see, you can clearly say that there are more number of female clerks as compared to male clerks. There are no female custodials. You have male custodials. The red bar corresponds to the custodial category. And finally, what you have is the green colored bar, which corresponds to the managerial category. Now, you obviously have more number of male managers as compared to female managers, right? So a bar chart or a cross tabulation can be used as initial or preliminary level of analysis to do a chi-square test. Now, we have still not run a chi-square test. This is the stage wherein I'll be running my chi-square test. So please follow these steps carefully. I'll be going to the Analyze menu. I'll follow the same sequence of steps. I will go to Descriptive Statistics. From here, I can just choose Cross Tabs. the earlier settings which I had sort of enabled, the earlier choices that I have made are being displayed here. Now, to do a chi-square test, please observe from the top, you have to look at the second tab, which is the statistics tab. Please click on this particular option. And once you click on this particular option, you have a lot of interesting options here. But I'd like to draw your attention to the first and the most important option here, which is chi-square. We'll be running a Carl Pearson's chi-square test here. Remember, you've got correlation and such things. I'm not interested in these options at this stage. I'm specifically interested in running a chi-square test. So please click on continue and then choose OK. Right. As before, I'm getting a case processing summary, a cross tabulation, but I'm really interested in the chi-square test. Right. Let me just double click on this. Right. It is giving me a pivoting tray and such things. I'm not interested in any of these things. So you can see the Pearson's chi-square value being displayed as 79.277. Very important. Below this, I've got the likelihood ratio test also being conducted here. And what is the likelihood ratio value that is being displayed here? This is the calculated value that you'll be obtaining. The second column here is DF, which is nothing but the degrees of freedom. Now, I'm not, your teachers, your lecturers would have, in your classroom session, practical session, would have asked you to compare the calculated value with the table value. Now, that's a different approach of, doing hypothesis testing, wherein you compare the calculated value with the table value. I'm not following that particular approach. I'm following the p-value approach here, right? Now, though it displays as 0.000, it is not exactly 0.000. It may have a lot of zeros here, and then in the 18th or the 19th position, you may have a number. But for all practical purposes, I will just consider the first three decimals here, 0.000. Now, what is this 0.000? This 0.000 is nothing but my p-value. P stands for probability value. Probability value always lies between 0 and 1, which means it can't exceed 1. You can't get a probability value of 1.2, 1.3, or 1.5. You can't get a probability value which is negative, right? So in this case, I'm getting a very, very tiny value. It is not precisely 0, but it's a number which is very close to 0, 0.000, right? This is the probability value. I will just pull out this value, and I will go to my PowerPoint presentation. Remember, we had set up our hypothesis. This is the null. This is the alternative level of significance. Chi-square value just now you have seen is 79.277. Where did I get this value? I'm referring to this particular value, 79.277. And I'm looking for the p-value here. Now, the p-value turns out to be 0.000, right? So in bracket, I'm just going to write this value 0.000, right? Now, I need to compare this probability value with 0.05. Question is this p-value less than 0.05? Please focus on these two numbers. You'll have to focus on these two numbers. That is, compare 0.000 with 0.05, right? Very, very easy, to do this. If the p-value is less than 0.05, you straight away go ahead and reject your null hypothesis. On the other hand, if your p-value is bigger than 0.05, you will have to basically accept your null hypothesis. I'll just copy this value. Right? There are two cases. One is P is less than 0.05. Second case is P is bigger than 0.05. Ask yourself a simple question. The P value that we have obtained, is it smaller than 0.05 or bigger than 0.05? The answer is very, very clear here. P value that we have obtained after doing the chi-square test is smaller than 0.05. I repeat, it is smaller than 0.05. In which case, what you do is you basically reject your null hypothesis. You reject your null hypothesis. Your null hypothesis simply goes away, right? So let me just reject my null hypothesis. My null hypothesis becomes redundant henceforth. If my null hypothesis is shot down, if my null hypothesis is wrong, then what would I conclude? I would conclude by saying that since the p-value, this is my inference, please follow what I'm doing. Since p-value is less than 0.05, we reject H naught. We reject H naught, which automatically means that I will be going by my alternative hypothesis. So you can just complete this sentence by saying we reject H naught and conclude. What are we going to conclude? We conclude that there is a relationship between job category and gender. Let me just copy paste this. I can just delete this. Now, this is the inference that I'll be making. My p-value is less than 0.05. So I will be rejecting my H naught and concluding that there is a relationship between the variables gender and job category. Remember, frame the null hypothesis, frame the alternative hypothesis, set up the level of significance as 5%, need not always be 5%. You can also choose 1% or 10%. You can choose the test statistic. SPSS has a responsibility. SPSS, R or Python, regardless of which tool you use, these tools give you the calculated value. They also produce the p-value, right? So if you have the p-value in front of you, it becomes very, very easy for you to either accept or reject my hypothesis, right? Accepting is a wrong word here. We usually do not use the word accept. We say either we reject H naught or we do not reject H naught, right? One simple rule of thumb. Many times people ask me, how do we remember this? Sometimes we get confused whether we should reject or accept when it is less, right? So remember this statement: if P is low, null will go, right? If P is low, null will go. I'll repeat it. If P is low, null will go. On the other hand, if P is high, null will fly, right? If P is high, null will fly. If this helps you remember, it would be amazing, right? So please keep these sentences in mind. If P is low, null will go. Null will go in the sense I will kill my null hypothesis. I will reject my null hypothesis. On the other hand, if P is bigger than 0.05, I will not reject my hypothesis. The p-value that I got when I performed this experiment was 0.000, which is clearly less than 0.05, and hence I'll be rejecting my null hypothesis and concluding that there is a relationship between gender and job category. I thank you very much for watching my video. I request you to subscribe to my channel. I request you to click on the like button and share my videos with your friends and relatives. I'll see you in the next video. Thank you very much.